Assalamu alaikum. This is a question on rotation. It reads, a 45 Newton block is suspended by a massless light string from 2 kilogram pulley. The block is released from rest and falls to the floor below as the pulley rotates. The pulley may be considered as a solid disk of radius 1.5 meters. Find magnitude of acceleration A of the block. So we have here a diagram or a figure of the problem or the equation. So we have, this is a block, this is a pulley. This pulley has a radius of 1.5 meter. So this is the radius of the pulley, R, 1.5 meter. And the weight of this block, weight equals mg, is given as 45 Newton. And since this is the direction of motion, so I expect the acceleration to be downward, because this block will cause its weight will cause the pulley to rotate. So the acceleration will be downward. And the question is asking for the acceleration of the block, the linear acceleration of the block. So find the magnitude of the acceleration of the block. So in order to find the magnitude of acceleration, we can use Newton's second law, sigma F equals ma. And in this situation, we need to know all the forces affecting the block, which is in addition to its weight, also we have a force of tension. So this force of tension, now we can write the equation as T minus mg should equal ma. But we know that the acceleration is downward, so we can add a negative sign here. Now, this T is unknown, minus mg, which is the weight of the block, given in the question as 45 newtons, should equal minus the mass. If we know the weight is mg, which is, so it is the weight by g multiplied by a. Okay? So this will give 45, the weight, divided by 9.8 multiplied by a, and this will give 4.6 a negative. Now we can leave this equation and we call it equation 1. The reason, I can find a, but I have one unknown I need to figure out, which is the tension. So in order to find the tension, I can go back and I can see that this is the same tension affecting also the pulley. So I can utilize the torque equation, the corresponding equation to Newton's law in terms of torque. Sigma torque should equal I alpha. And here I have my I, or rotational inertia, is for the disk. So the only torque affecting this pulley will be the torque from this force, the tension, multiplied by cross product with the radius. So it should be radius of the pulley, so it should be R T should equal I alpha, which will give that T should equal I alpha divided by R. But we know that I is for a disk, and for a disk, it is half, it's like a cylinder, so it is half m r square alpha and alpha divided by r, and we know that a equal r alpha. So we can also incorporate this as alpha equal a divided by r. So we can also substitute for alpha here as a divided by r. So now we know that this r will cancel out with this r, will cancel out with this r, and the mass is 2. So the mass here, the tension will be half multiplied by the mass 2a. So this will cancel out. So I know that my tension should equal the magnitude of my acceleration. Now I can go back and substitute in equation 1. So substitute in 1, since we know now the tension in 1, which will yield that t minus 45 will equal minus 4.6 by a. Now my t, I will substitute as a minus 45 should equal minus 4.6 a. So now I need to find a, so I can take this to this side, can take this to the other side. So 45, or can take this here, so it will be 5.6. A should equal 45, which will give that A equal 45 divided by 5.6, which will give 8.1 meters per second square. And this is the magnitude of the linear acceleration of the block moving downward towards Earth. Thank you.